Welcome back. We are going to work on 10-2 today. I'm going to break up the video into two pieces. So you're going to do the first half of the notes through example 3, and then we're going to try the first 5 problems in the homework. And I'm going to make a separate video for the back page, examples 4 through 7, and then that will get you through the rest of the homework. So we're just going to do the first part of the notes in this video. Stop, do your homework, come back and watch the second video and do the rest. This section is really mainly about some new equations. We have general forms here of the arithmetic sequence. We can write an equation for any term of an arithmetic sequence if we know the first term, A1, the number of the term that we want. So maybe if they ask you for the 10th term, you could plug in 10 to this equation and find out what that would be. And D, which is your common difference. And this is only for arithmetic, so when we're adding and subtracting a number to create the sequence. So A1 is first term, N is the number of term. So if they're asking you for a specific term, you'll use that number for N. And D is the common difference, plus 2 minus 6. So you really have to look at, when you're doing your common difference, maybe make yourself a note that this must be, oops, if it'll let me type, must be the second term minus first term. If you're doing it backwards and you're going first term minus second term, then your common difference is going to be wrong. Okay, we're also going to talk about the arithmetic means. And means here normally means average, a mean, but not quite in this situation. So if we say, so A, I'm going to use just a regular one, but A sub 1 is your first term. Then you have some term here, another term here, another term here, and then we have A sub n. I can't do subscripts here, but you get the idea. Then the arithmetic means are just these things in the middle, the terms in between any terms in a sequence. And they're not consecutive terms. So the means here would be, maybe this is 3, 4, and 5. You would have to name all 3 terms. An arithmetic series, so from here to here, arithmetic series, partial sum, sigma notation, let's see if it'll help me here. These things here are going to be the second video. Okay. Darn. Well, let's put this back in. So those are your arithmetic means. From arithmetic series down to sigma notation is in the second video. So we're going to ignore those for now. For the first half here, we're going to be using this equation. A sub n equals A sub 1 plus n minus 1 times D. Alright, so let's go down to example 1. There we go, it's gone. Okay, find the indicated term of each sequence. So we're going to start, and I'm actually going to go to a Word document to try and make this work easier. If this doesn't work out as easy, I may switch to doing them. I've got a whiteboard in one of my rooms here at the house, so we'll see. We may have to switch to that. But we know that A sub 1, or the first term in the sequence, is negative 12. The number of term that we want is 66, the 66th term. So you're not going to want to do what we did in the last section and write out all 65 terms to get to the 66th. And the common difference is we're adding 4. Positive 4 means we're adding 4. So we will use our basic equation here. A sub n equals A sub 1 plus n minus 1 times D. Okay. Make some room here. Alright, we're going to use this equation. Why is that? Oh. Okay. And we're going to plug in what we know. So we'll take this same thing and we will fill in what we know. So a sub n, what is my n? I'm going to write a sub 66 because I want the 66th term. A sub 1 is going to be negative 12. N is 66. And D is 4. So you literally just fill in what you are going to use. And then we just have some simple math to do. So let's copy this again. A sub 66 will be, well, this is going to be 65. We'll have to figure out what 65 times 4 is. And I don't really care that if you show me every step, you could just put this in your calculator and say, okay, I can do negative 12 plus 65 times 4 as long as I do that first. And I'll get that, whoops, this math becomes 248. So that would be your answer right there. So I wonder if I don't think I can. I'm going to leave it like that.
So the impact round.
Then if we go over to part B, and I'm going to do it right here. Here we're given a sub 15, and we have a sequence, negative 5, 12, negative 19. So this is the beginning of the sequence, so we have to say, okay, what do we know? I can tell you, I want to know these pieces. Okay. So do we know a sub 1? Okay. A sub 1 is the first term in our sequence, so that is negative 5. So let's fill in negative 5. Do we know n? It doesn't tell us n, but we can see a sub 15 here. That's telling us that n is 15. Do we know our common difference? It doesn't tell it to us like it did in the first problem, but we can figure it out. We'll say negative 12 minus negative 5. So I'm going to even write that. Negative 12 is our second term minus negative 5. That's going to be equal to negative 7. So these are getting smaller, so it's going to be a negative, and it's going by 7s. Okay. So we can take that and then fill in our equation. So let's fill in what we know. A sub n, our n is 15. A sub 1 was the first term in our sequence, that's negative 5. N, again, is 15. And D is negative 7. So we just have to figure out what this is. And to make life easier, you can literally just put this expression in your calculator, or you can say, I know that negative 5 is, this will be 14, negative 7 times 14. I don't know if I even did that. Nope, I didn't. I just figured it all out. So let's do that all in one step and get that a sub 15 is negative 103. So that would be your final answer. Find the indicated term. We want what is a sub 15. Okay, then for example 2, step back over there. For example 2, write an equation for the nth term of the sequence. So we have to write the equation. But once again, we're trying to identify these pieces. We need to find our first term, our n, and our common difference. Okay? So maybe over here in your notes, we can say for these, define first term n, let's see. Well, we're looking for the nth term, so we don't want n. We want the first term and the common difference. Those are the things we need to be able to do that. So if we come over here, can we say that we know what a sub 1 is? There we go. So a sub 1 is just the first term in the sequence, so it's 31. And do we know the common difference? Yes, I can get that from 17 minus 31, or negative 14. Those are the things you need to write your equation. So then we'll go and take our general form and fill in what we know. And we're going to fill it in, and then we're going to write it so that it's in the form of a linear equation. So a sub n is what we want. We want an equation for the nth term. We keep that the same. A sub 1 we know, it's 31. N is fine. We want to keep it as n. And our common difference was negative 14. So here, this step is fill in to general form. Alright, then we're going to solve and make it into a linear equation. So we'll take this and we will distribute the d. So we'll take the negative 14, and that will give us, this will become minus 14n, and then negative times a negative is plus, plus 14. Oops. Minus 14n. So if I distribute the negative 14, you get minus 14n and plus 14. And then you just combine like terms. And we take this, and we get 31 and 14 will be 45. So this is our final answer. Okay, so let's do the same thing for part B. We need to identify a sub 1 and our common difference. Well, we don't have that, but we can find it because we know that a sub n is 45 if n is 9. So we've got to come back up here and steal our general form. We're going to use what we know to find. Okay, so let's say use what you have to find a sub 1. So we have a sub n. Hold on, let me fill this in. We have a sub n. It's 45. We don't have a sub 1. We do know that n is 9 because it's stated here that this is a sub 9. And we do know that d is negative 3 because they told us. Okay, so we're going to combine like terms and solve for a sub 1. So let's see what we can do. This will be all of this becomes 9 minus 1. Okay, that's 8. 8 times negative 3, that's minus 24. Minus 24. So then we just solve for a sub 1, and we will get, hold on, so that is 24 plus 45. 69 is a sub 1. Okay, so we found a sub 1, we know d, use a sub 1 and d to write the a sub n equation. Okay, so we know a sub 1 and we know d is negative 3, and so we're going to do this step again. So a sub 1 in our new problem is 69. We solved for that. D is negative 3. So if we follow the steps again, we distribute and we get that this becomes minus 3n plus 3. Combine our like terms, and we end up with negative 3n, and 3 plus 69 is 72. So that would be your final form. Those are the most straightforward things that we have. Then we have this arithmetic means problem. So let's just slide that down here. So the arithmetic means problem, we have to figure out what these values are. So we're going to get to those later. Okay, so we have to do a couple of things. We know our sequence will have 6 terms. So we could even number these and say that the 84, that's term number 1. This one will be term number 2. That'll be term number 3, 4, 5, and 6. So what does that allow us to say? Well, we know that a sub 1 is our first term, so that's 84. And we know that our a sub n is actually the 6th term, and that is 39. So we know a sub 1, we know a sub 6, and we know that we're using that n equals 6. So we have to use our general form to try and figure out those middle terms. What we don't know, D, and that's what we need to be able to find it. Because if we knew what the common difference was, we could say, okay, well, 84 is going to be minus something, but 84, maybe it's minus 5. So minus 5, minus 5, minus 5, we could use that to find these terms. But we don't know it yet. So we're going to use the general form to find that. So let's start here. What can we fill in? We know a sub n. It is 39. We know a sub 1. It's 84. We know n is 6. And if we fill all that in, the only thing left in the problem is d. So we can figure it out by simplifying this. So we fill in what we know and solve for d. So this is just simple math here. We need to say that this becomes 5d, and then we'll subtract the 84 from both sides, which ends up 39 minus 84 is negative 45. And then we solve by dividing, so let's just say here, fill in what we know, solve for d. We simplified that to 5, subtract 84, and then we will divide by 5, and we will get that d equals negative 9. So once we have that, our last step, use to find missing terms. So we get 84 minus 9 is 75. We'll, just like we did in the last section, subtract 9 again. 66 minus 9 again is 57. Minus 9 again is 48. Oops, that should be an equal sign there. Okay, so we've done all this work and now we have our terms. So the arithmetic means are the missing terms. So it is 75, 66, 57, and 48. That's your answer right there. So this will allow you to do the first 5 problems in your homework and the first couple of problems on the worksheet that you can work on. I'll make another video here in a little bit for finding sums and using the sigma notation. So you should only be going through, I believe it's number 48, first 5 problems in the homework, and I will add that video to this post once it's ready. Good luck!